Okay, in this video we're going to cover using a game manager script to better organize your code, the difference between public and private variables, using code to instantiate prefabs so that they can be more dynamic in their placement. We're going to re-go over the vector-3 coordinate system just to make sure you have a good understanding. We're going to look at for loops for the better first time, and how for loops can make your code be more dry. And finally, we're going to look at generating random numbers so that when we do use for loops, everything is not in the same location. At the end of the Unity tutorials, this is what we have. So we've got our ball that can go around. We can collect all of the pickups. And then it comes up with the word you win, and we can still move our character around. Okay, so the first thing we want to do is make it so these pickups don't appear. That's fairly simple. Over here in the hierarchy, if you go to pickups, because we've grouped them together, all we have to do is select the root of the hierarchy here and uncheck it, and they're all gone. We'll just leave them there for now. We could technically just delete that whole line, but we'll leave them there for now. We may want to use them at some stage. Okay, the next thing we want to do is we're going to create a new script that will actually generate the random pickups that are going to be placed. Okay, so we're going to right click on script, create, C#. We're going to call this game manager. Game manager, make sure it's spelled correctly, press enter, and you will notice it's got a special icon there. Alright, it's because Game Manager is actually a special script that Unity recognizes. Okay, so it's a common script for most games to have. Okay, so what we need to do inside the Game Manager, and I'll go to the script now. So inside the script now, the first thing I want to do is create a reference to those pickups. So once again, that has got to be public. That means that I can access it within the Unity environment. I'll show you what that means. So it's going to be a game object. Oops. Game object. And I'll just give it a name. I'll just keep it consistent, so I'm going to call it pickup. Notice that I'm using what's called Pascal case here. No, camel case, sorry. So every new word is capitalized. So there's no spaces in variable names. That's quite important. But the first letter is lowercase. Sometimes we use an uppercase for classes and things, which I'll explain a bit more later on. But for simple variable names, we're going to do lowercase for the variable, for the first letter, and then every new word, no space, but just put in a U, an uppercase letter for it. Okay, so actually I'll start by making that private, just so you can see, just to reiterate what the problem is. So if I go there, now if I go back to my minigame, we need to create a new object up here. It's just going to be create a new object, create empty, and it's going to be called Game Manager. Okay, and we need to add this Game Manager script to that object. That's an empty object, so it doesn't actually do anything. It just sits there on the screen to manage the game, hence the name Game Manager. You'll see here that over here there is no slot for me to assign the pickups, and that's because I made it a private variable. If I go back to my script and make this one public, and now I go back to my game, alright, over here you can now see that it says pickup, and it's got a slot there for us to assign. Now I'm just going to drag in my prefab into that slot. Nice and simple. That means that now my script now has access to that prefab. Okay, now I'm going to basically, quite simply, the first thing I want to do is I'm just going to spawn one pickup to show that it works. Now there is a piece of code that is called instantiate. Okay, instantiate. It'll come up. Alright. See there, it gives me a bit of pop-up help to do. So clones the object original and returns the clone. So basically makes a clone, makes a copy of it. So bracket, what is the original object we want to do? Okay, we're going to call it pickup. And now we want to do the location of it. Where do we want to put it? Okay, for now, we're just going to put it into, create a new variable in the spot. We will tidy this up a little bit later, so we'll go new, it's a new vector 3. Now remember, a vector 3 is just an x, y, z coordinate system, and I'm just going to put in numbers here. I'm going to put in 2, 0, because we don't want to, oh, actually I think it was 0.5, wasn't it, comma 2. Okay, so that means that it's going to be stored on the screen. It's going to be x is going to be a 2. So if we go back to our Unity just to see what that might look like. Alright, so this is x, this is z, y is, if I rotate this around, y is that angle. So we're not actually dealing with y at the moment. So that's why we only want y at 0.5, because that's what we've been doing before for the height of the pickups. That's the height they are off the play area. So that's x. So our object will be 2 Unity units across and 2 Unity units up and 0.5 off the ground. Okay. Now we've still got an error here that it doesn't like, and that's because I've gone 0.5. I need to put an f after it to indicate that it's a float. Okay, the next thing I need to do is I need to say the rotation of the pickup. That's pretty simple. All we're going to do is write pickup dot transform dot rotation and end with a semicolon. Okay, so let's just have a look at this. This instantiate creates a new copy of a object, the prefab. The prefab it's doing is pickup, which is what we've assigned here when we dragged it over inside Unity. It's going to place it at this location, which is a vector 3 coordinate, which is x, y, which is the height, z, which is the back and forward coordinate. So it's going to be 2 across, 0.5 off the play deck, and 2 up. And then when it gets placed, it's going to have this rotation applied to it. I could have just said 0. That means it will have a rotation of 0. But I don't want to do that. I want to place it with whatever rotation my pickup has when I created it. If I go back to Unity and we look at the pickup under transform, we assign these 45, 45, 45. So I want it to start with that rotation value. Alright, I want it to be rotated on 45 on the X, 45 on the Y, 45 on the Z, just to keep things nice and consistent. Yeah, that's what this does. This looks at the pickup, the original pickup, the transform property of it, and then looks at the rotation value within the transform property of it. So all this stuff inside here is the transform properties. So I could look at the rotation, I can look at the scale, I can look at the position. In this case, I'm just looking at the rotation values, and I'm basically taking all of those rotation values and applying that to the new object that's been instantiated. Okay, if I save that now and go back to my Unity, and now I push play, I've got my one object started and it's happily rotating along. Okay, so that will be technically 2 across, 2 up, and 0.5 off the play deck. Okay, so the next thing I want to do is scale this up, so I've got 5, 10, 15, 20, whatever it's going to be of them. So I'll pause that and I'll go back to my script. Actually, the first thing we'll do is we'll create a couple of them. Okay, so let's say on start, I want to create 5 of them. Okay, and they've all got slightly different locations. Whatever, now save that, and I'll go back to Unity, and there's my 4 of them. Obviously 2 of them are at the same location. That's okay. So I could just do that. There's a couple of problems with that approach. The first being one, we've repeated the same piece of code over and over and over again. Now, generally, when we are creating code, one of our goals is to make the code as dry as possible. Okay, by dry, D-R-Y, that stands for do not repeat yourself. Okay, so whenever possible, with any code you're doing, this should be something that's always in your back of your head. This will serve you well through most of your coding. All right, you do not want to repeat yourself with any line with piece of code. If you're looking at your code and you see pieces of code that are repeated over and over again, there is probably a better way of doing it. So if we look here, these 5 lines of code are almost identical. The numbers change slightly, but we can handle that, but it's more or less the same lines of code. So the question to you is, how do we, with only having 1 line of code, because we don't want to repeat it, so if we only have 1 line of code, how do we go about creating 5 or 10 different pickups on the screen? I'll just give you 5 seconds to have a think about that. So we're going to start using a for loop. This is the basic structure for a for loop. Use the keyword for. There's some stuff inside the round brackets here. Okay, the first thing we're going to put in here, which I'll expand on in a second, is the start, and that's the finish, and that's the increment. So if I made, and it will do this piece of code. So if I had it said print hello, okay, semicolon, it would print hello. So let's just keep this really simple. If I said the start is 0 and the finish is 4 and it incremented by 1, this is not how it looks. I'm just trying to simplify it down a bit. That would start at 0, go up to 4, increment of 1. So that would print hello 4 times. 0, 1, 2, 3. It wouldn't do the 4th one because it stops at the 4. Does that make sense? But that's not how it looks. All right, we've got to expand on that. So in C#, the way that it works is first we need to declare a variable. So we say int, and the most common to use is I. We don't have to use I. Please don't auto-capitalize that. Okay, so that's saying we're starting at 0. How long are we going to do that for? We're going to do that. You should be semicolon, sorry. We're going to do that for as long as I is less than 4. Okay, so we're going to say I equals 0, start at 0, and we're going to keep doing this loop. Whatever's between this squiggly bracket and this squiggly bracket will keep going as long as I is less than 4. Now, in order for that to be successful, I has to increment, because if I stayed the same, this would go on forever. Because the first time it rotates around, I is 0, do it. The next time it's 0, do it, etc., etc. So we need to increment I. So we're going to go I equals I plus 1. So that means every time it goes through, it's going to increment I by 1. All right, so the first time it goes through, it'll print out hello, I equals 0. The second time it goes through, and we'll make that a little bit clearer. If I wrote under that print I, remember it needs to be tabbed across. Okay. So if I had that in my code, in fact I'll put that in my code so we can see what that does. So if we look at the code, I've pasted it in now. I've made it a lowercase p, so that should have been a p, and I had to replace those brackets because they copied across wrong. Those quotes because they copied across wrong. Other than that, this is perfectly okay. So if I now go back into Unity and run that piece of code, what would you expect to see? Concept, hello, 0. So that's the first time it goes through, I equals 0. Hello, 1, I equals 1. Hello, 2, I equals 2. Hello, 3, I equals 3. Stop. Why does it stop at that point? It stops at that point because the next number would be 4, and 4 is not less than 4. Okay, so that's the basic structure. So let's just take this now, and we will cut that into place. Okay, notice that it's tabbed over. It's 4 spaces, by the way. That's quite important. You need to follow common conventions when we're programming, and one of the common conventions within C# is that every structure that is part of another structure gets tabbed over 4 spaces. So this opening bracket and this closing bracket, everything that's in here is part of this statement here. So it's tabbed over, it's spaced over by 4. All right, we've got another start function here, or method, sorry. There's a squiggly bracket there, so everything that's part of that gets tabbed over by an additional 4. All right, we've got a for loop here, so everything that's inside that squiggly bracket and that squiggly bracket gets tabbed over by an additional 4 spaces. Okay, now if we save that now, and we run that, all right, we can see over here that there are 4 clones, but I can only see 1. What's going on? Right, they are all in fact in the exact same location. So we haven't gained a hell of a lot here because we've created 4 pickups, but they're all in the same place. So what do we need to do now? We need to make it so they appear in different locations. What is the best way of achieving that? So what we're going to do is we're going to use another function built into Unity, which is called random. Okay, do it here. I'm going to create a new variable. I'm going to call it float. It's going to be a float. A random is going to be a float, because we don't want to deal with fixed numbers. We want to have any possible number. Spawn position x equals random dot range. Okay, and I'm just going to do, I can't remember how big my square is, so I'm just going to say, I think it was 10 across. So I'm just going to go from 9. So that means we'll start at -9, sorry, and we'll go up to 9. Okay, does that make sense? So we've got, we're generating a random number. So random.range. It's a special function there. If you look at the help text there, return a random integer between, in this case it'll actually be a float, but that's okay. And then that will get stored in this variable, yeah, which we've defined it as a float. Now we just need to use this variable. So if I paste that there now, okay, so every time this loops, every time this goes around, which in this case is going to go around 4 times, it's going to generate a random number between -9 and 9 and use that in the placement of our pickup. So if I save that there now, and I'll go back to Unity and push play, where would you expect them to be placed? Alright, so they're all on a straight line, because remember in my code I have randomly selected the x value, which is this value, but I haven't randomly selected the y value. Okay, which I'll leave you up for you to do before the next video.